All right, good morning, everybody. So we're now past the point in the course where I'm showing you how to do things in Python and then, where I'm taking things that you learned in Python and showing you how to do them in Java. So there's still a little bit more of that we have to do, but we are starting now on the, on the actual object-oriented programming part of the course. And so the set of lectures that we're on is called Creating and Using Objects. Right, so far in the course you've used, we basically used primitive values. You've used a couple of objects already, so you've used a random number generator in assignment 1, but the assignment basically told you how to use the random number generator. We talked about strings in the previous class, but Java tries to go out of its way to make strings behave like they were primitive, even though they're not. So it's possible to create a very sophisticated program using only primitive values, but it's inconvenient to do so. So almost any non-trivial Java program is going to make use of objects of some kind. Right? And so the question is why do you want to use these things called objects instead of using just primitive values? And so the answer is that objects can perform more operations than the primitive values can. Right? So if someone gives you a string is capable of doing a lot of different things, right? It can give you its uppercase version, its lowercase version, you can get part of the string, et cetera, et cetera, et cetera, et cetera. Right? So the string class lets string objects perform many, many, many types of operations. Right? If it didn't provide those operations, the programmer would have to provide those operations themselves. Right? And so when if you take Sys 220, when you learn the C programming language, what you'll end up learning is how do you make a C string do stuff like a Java string can do. Because the C language doesn't provide you with any sophisticated string operations. All right, so what exactly is an object? Well, an object is just a thing. You can think of it as being an entity in your program, and it stores information. And it provides behavior. Right? So the information that it stores, or data that it stores that information in something called a field or fields. So the fields of an object, they can be primitive type. So you might have an object and internally all of its data are just ints or doubles or booleans or something like that. But more generally, the data that it stores, it's actually storing reference type data. So in other words, an object can be made up of other objects, and those objects can be made up of other objects, and so on, and so on, and so on. Right? And that lets you make, so starting with very simple objects, that lets you make very complicated objects. So the set of values, or the data that an object holds, that's called the state of the object, right? And so when you hear about, when you read about object-oriented programming, you'll often hear about the state of your objects, right? That's just the data that the objects are holding. Oh, so I guess the important part here is that the data can change over the lifetime of the object, right? And so that means your state is not fixed, but can vary. Okay, so the other nice thing about objects is that objects can perform actions, right? So the objects have methods that you can call, and that lets the object operate on the data that it's holding to compute some sort of to perform some sort of computation. Right? And so objects can talk to one another. So one object, if it has a reference to another object, it can ask the other object to perform some action. Right? And so a typical Java program is made up of many different objects that all interact with one another. Right? Okay, so the object lifecycle is as follows. Right? So if you want to use an object in your program, you have to create the object first. Right? So we say that an object is born. Right? Once the object is born, you can then use the object to perform some sort of task or tasks. Right? And then eventually, it's probably the case that you no longer need this object anymore, and so you want to destroy the object. Right? The reason you want to destroy the object is because your object is taking up memory in the computer, memory and other resources. Right? Memory and other resources on your computer are finite, So when you're done with an object, it makes sense to remove the object from your program, freeing up the memory and what other resources it's using. And so in Java, the programmer controls, or the programmer can control when an object is created, right? They can control, or they have control over the use of the object. So the programmer makes an object, uses the object. But what the programmer doesn't do in Java is explicitly to get rid of the object, right? So in Java, you make an object, you use it, and then you don't worry about it, right? When it's no longer needed, the language itself takes care of removing the object from memory and freeing up its resources. And so Java uses a technique called garbage collection for step 3, for destroying and removing, freeing the resources used by no longer needed objects. And if you click on that link, you can learn a little bit more about garbage collection in computer science. Okay, so I guess again, so if you take SIS 220, you'll learn a programming language called C, and in C, the programmer is now responsible for also removing objects that are no longer needed. Okay, so how do you make an object? That's step 1, right? So step 1, objects are created using the new operator, right? And so you've seen this already. When you make a new array, when you make an array in Java, you use new, and then the type of element and the number of elements that you want, right? So that's an example of creating an object. So arrays in Java are in fact objects. So you've used objects already, whether you know it or not. So whenever you want an object, you're probably calling new. It's possible that you can call a method somewhere that returns a new object, right? But that method eventually has to call new to create the object, right? Someone has to call new to make the object, right? So all objects are born using the new operator. So the new operator is responsible for doing 3 different things, right? So all objects, all data on your computer occupies memory. So new is responsible for getting the memory needed for the object. So it allocates memory for the object. New is also responsible for initializing the state of the object. Right? Now new doesn't initialize the object itself. Instead, it uses what's called a constructor to initialize the state of the object. Right? So when you make a string, if you make a new string and you don't tell Java what string to create, you end up with the empty string. Right? So in other words, when you creating a new object should put the newly created object in a well-defined state. Right? You don't end up with some random string, you end up with the empty string. It's similar for arrays. When you make a new array in Java, Java populates the elements of the array, right? So that you actually have elements in the array. Finally, after it's allocated memory, call the constructor to set the initial state of the object. It then returns a reference to the new object, right? And that lets the programmer, so the programmer now has a variable, can store the reference in a variable, and then they can use the variable to call methods on the object. All right, so here's an example of using new to create some objects. So here I'm using the class called point2. Point2 is part of the, is one of the classes that's talked about in the course notebooks. You have the source code for it if you want to. If you want it. So that's one of the classes that I use in this lecture. Right. So I want to make a new point. So my type is point2. I can make a variable p1. Right. So p1 is able to store a reference to a point2 object. Right. And so to make a point2 object, I use the new operator, and then I call a constructor belonging to point2. So the rule in Java is the name of the constructor is exactly the same as the name of the class. Right? So here I want to make a point2 object. So the constructor, its name is point2. Right? Calling a constructor looks a lot like calling a Python function. So name of the constructor, round bracket, round bracket. Right? Some constructors have parameters. So the programmer passes arguments to the constructor. So that's an example of the second constructor call here. Right, so P2 is also a point2 reference. Right, so I need to make a point2 object, so I call new, I call a constructor. Right, now the second constructor here takes in 2 values, here 1.0 and 0.5. So this makes a two-dimensional point whose coordinates are 1 and 0.5. That's what point 2 is. Point 2 is just a two-dimensional point that corresponds roughly to a real point, a real two-dimensional point in mathematics. So the first constructor makes a point whose coordinates are 0, 0, so it gives you back the origin. Right? Second constructor lets the programmer say what are the coordinates of the point, so here it gives you back a point 1, 0.5. The third constructor here takes in another 0.2 reference, right? So P2 is a 0.2 reference. The third constructor makes a new point by copying the state of an existing point. So the third constructor here copies the point P2 and initializes the third point so that its coordinates are the same as the second point. Right? But you really do have 3 points here. You have 1, 2, 3 different point objects. They all have their own coordinates. And they're independent from one another. Right? So if I change the coordinates of P1, the coordinates of P2 do not change. Right? If I change the coordinates of P3, the coordinates of P2 also don't change. Right? You have 3 independent objects. They have their own state. Right? When you call methods on the object, they operate on their own coordinates. Right? Here's an example of using this thing called a scanner. So if you read virtually any introductory Java textbook, you will come across this class called Scanner. Scanner is a class that you can use to get input from the keyboard, among other things. Right? And so a lot of introductory courses have you write little programs where the user interacts with the program by typing stuff in. Outside of an introductory programming course, you almost never do this. Right? And so I never show you actually how to use a scanner. If you want to use a scanner, though, this is an example of how to create a scanner that can read keyboard input. Right? The only purpose of this slide is to show you how to make an object. So there's this class called scanner. I can make a variable. In this case, it's called S1. Right? So this S1 can store a reference to a scanner object. How do I make a scanner object? Well, I call new. Right? When I call new, I need to call a constructor. Right? So I call a scanner constructor. Right? Name of the constructor matches the name of the class. If you want to read the keyboard, you have to pass in this thing called system.in. This happens to be something that corresponds to your keyboard on a desktop computer. Right? Any computer that has a keyboard, system.in probably points at the keyboard. Similarly, you can create a scanner that scans the contents of a string. So here's another example. I make another scanner. Right? So new scanner. And this time I pass in a string. So scanner S2 is able to read the contents of the string and extract the parts of the string. In this case, the parts of the string separated by spaces. Right? So there's another example of creating an object. Okay, so when you use new, you always follow it with a constructor call. Right? The constructor, calling the constructor looks like calling a Python function. Right? Sort of looks like a method call in Java. But in Java, constructors are not considered to be methods, right? So constructors are their own thing. Right? One of the big differences between a constructor and a method is that a constructor does not return a value. Right? So all methods in Java return one value or void. Constructors never return anything, not even void. So that's one of the big differences. The other big difference is the constructor, you can't freely name constructors. Right? The name of a constructor always matches the name of a class. Okay, so where are these constructors found? Well, it turns out you find them inside the class that they're defined in. Right? So that's where you put them. So when you make a class, you can also put in a constructor or constructors if you like. Right? What do constructors do? Their job is to initialize the state of a newly created object. Right? So that's why they're called constructors. They construct the state of the new object. Okay, so there's two types of constructors in Java that are notable. Right? So the first type of constructor that's notable is the constructor where the user passes in no information. Right? So you call the constructor and there's no arguments to the constructor. Right? Not surprisingly, this is called the no argument constructor, right? Because it's the constructor that takes no arguments. Right? The purpose of the no argument constructor is the same as every other constructor. Right? it initializes the state of the newly created object. If a programmer is calling the no-argument constructor, they're basically saying they don't know or they don't care what the initial state of the object is. Right? So the constructor still needs to set the state, and it should set it to a well-defined state. So you can think of the no-argument constructor as being the quote-unquote default constructor. Right? It produces some object that has some default state. For point 2, that constructor sets the coordinates of the point to 0, 0. Right? That seems to be a sensible default point if someone tells you they just want a point. Right? Whoever made the point 2 class could have picked something else here. Right? They could have made it 1, 1, they could have made it -1, -1, or something else. Right? It's under the, it's whoever created the point 2 class decides what is the default state of an object. Right? Now, not every class has a no-argument constructor. Right? So if you're using some class that you've never used before, and you write new class name, round bracket, that might not work because the class might not have a no-argument constructor. Right? How do you know if it has a no-argument constructor? You have to look at the documentation for the class. Okay, the second notable constructor that occurs in Java is something called the copy constructor. So the copy constructor is the third example here. Right? So it's a constructor that has one input, right? One argument. The type of the argument is the same as the name of the class. Right? And so that third constructor takes in another point 2 object. Right? So type of P2 is point 2. And so you have a constructor that takes in one point 2 object. Right? Same as the name of the class. Right? And so the purpose of the copy constructor is to copy another object. Not every class defines, a copy constructor. Right? Again, how do you know if a class defines a copy constructor? Well, you have to go and look at the documentation for the class to see if it defines one. Right? But if they're there, the no-argument constructor creates a default object. The copy constructor copies an existing object. Right? Every other constructor is just called a constructor. There's no special name for it. So that second constructor here, it's just a constructor. Right? And a class can define as many constructors as it wants, subject to some set of rules that aren't important right now. Right? So the third constructor in this class lets the programmer create a point, and they can specify both the x and y coordinates of the created point. Right? Again, how do you know if a class has extra constructors? You have to go look at the documentation for the class. Okay, I guess this is a good time to go look at the scanner documentation. So somewhere I have this, somewhere. Not here, not here, and not there. Here. Okay, so this is the documentation for the scanner class. So you can find this by Googling for scanner Java documentation or something like that. A little bit later on in the course, I'll actually tell you where you can actually find the documentation if you know its package name. Okay, so when you look at the documentation for scanner, you get a description of what the class does. Right? This description happens to be fairly long, so we'll just skip past that for now. Right? The second thing that you will normally see, you will see the constructors listed for the class. Right? And so when you look at the scanner class, you'll see that it has many constructors. Right? There's probably a dozen or more. Right? The one that you use to scan the keyboard is that one right there. Right? So that one takes in something called an input stream. Right? And the other one, the one that scans a string, is that one right there. Right? So that one takes in a string. But you can see there's lots of other constructors. Right? And if you try to read what these do, for most of you, they don't make any sense. Right? We don't know what a byte channel is. Right? We don't know what a path is. We don't know what a file is, and so on and so on and so forth. Right? Well, that's fine. Right? Some of these you can read, so you can read this one. Right? That's a scanner that takes in a string. Right? And of course, if you click on this, it takes you to the detailed documentation for the constructor. So that's where you find the constructors in the documentation for a Java class. Oh, sorry. Okay. Okay, so once you've got your object, so you've called new, you made an object, you now have and you stored the result of new in a variable, you can now use that variable to call methods on the object, right? So the way that you call methods on an object, you use the variable name, right? Then you write a dot, right? Then you write the method name, and then you pass in the arguments to the method. The method name arguments, that's like calling a Python function, right? Function name, whatever set of arguments are needed by the function. Right? The difference here is that you need to put in the reference to the object in front and then use the dot. Right? So when you write something like that, you're asking that object to perform that operation with these inputs. Right? So using an object, whenever you need to use an object, almost always you end up calling a method belonging to the object. Right? And to do that, you use the dot. Sometimes objects will make their data publicly accessible to everybody. A little bit unusual, but sometimes this happens. It happens in assignment 2. Right? So in assignment 2, you have to use one of these objects. So if the object makes its data available, then you get access to its data in the exact same way. Right? The data stored by an object, it's just stored in variables that belong to the object, so they have names, right? To get to the variable, you write the variable name, dot, and then the variable that belonging to the object that you want access to. Okay? So in assignment 2, you have to use something called, here. You have to use something called a mapping result. Right? So the mapping result has 2 fields. Right? If you can see the fields in the documentation, that means they're publicly available, which means you can use them. So one of the fields is called cars consumed. One of the fields is called value. So in assignment 2, you are creating a mapping result object, and then you're setting its value in cars consumed fields. Right? The assignment tells you how to do all of this. But there is an example of accessing a field belonging to an object. Somewhat uncommon to do this. It's somewhat uncommon to have public fields, right? But if you need to do that, that's how you do it. Okay, so here's an example of making a point. So here's my point, and then calling methods belonging to the point, right? So here I've got a point. I'm storing a reference to the point in the variable p. So if I want to do something with this point, I'm going to call methods belonging to p. So for example, p.x here. Right? So to get the x coordinate of a point, it turns out there's a method called x that has no arguments. That returns the x coordinate of the point. So in this case, it returns 0.5. Right? P.y gives you the y coordinate of the point. So in this case, it gives you 0.1. Right? Once I have x and y stored in a separate variable, right, I can change the value of x and y. So I can add 0.1 and subtract 0.1 to get 0.6 and 0. Right? Now I can change the coordinates of the point by calling another method. So in this particular case, you change the coordinates of you change the x coordinate by using the method also called x. Right? But this method has one input, right? It has the value of the new x coordinate. So p.x changes the x coordinate of p to whatever value x is, and p.y, y, changes the coordinates of the y coordinate of p to whatever y is. Set lets you change both the x and y coordinates in the same operation. So set x comma y changes the coordinates of p to x and y. Yeah, question? Field is data, method is a method. So field is data, method is behavior. Yes, these are methods, yeah. The point2 class doesn't give you an example in this case. So the point2 class doesn't make its x and y coordinate available to you directly by name. So this is not a good example. In assignment 2, you're going to make a mapping result object, and then you're going to set its value and cars consumed field. So you'll make an object m, and then you'll write m.value equals some string, and m.cars consumed equals 1 or 2, depending on exactly what depending on exactly what you're trying to do inside of the assignment. Right? But it's the exact same thing, right? So to set the field, it's just variable name dot, in this case, value equals something, right? So you treat the field belonging to the object as though it were a variable, right? m.value equals some string. m.cars consumed equals some number. Yeah. Round brackets pass in information. Either getting the value of the field or assigning a value to the field. Yes. So a field is just a variable. So that's the easiest way to think about it, right? So you can treat it as though it were just a regular variable. Oh, I can run this in Eclipse. Eclipse. Okay, so this is the point example right here. So I've changed the point example slightly so that you can actually see. I'm actually going to print out the result after calling every method. Right. So there's my point. I'm going to print out the newly created point. This is worth noting. So in Java, if you want to print out an object, you can just use the variable name corresponding to the object. Right. So here, if I want to print out p, I can just write system.out.println and then p. Here I put a string in front of it first, but it doesn't matter. Right? And so that will end up printing out the point, as you can see here. Right? So that line that's highlighted here produces this output here. Right? So it actually prints out the point in round brackets 0.5, 0.1. Right? So that's nice. I'll explain exactly how this works, probably in a few lectures. Right? So here we get the x-coordinate and the y-coordinate of p. Right? And then I change the x-coordinate here. So after calling that line, after changing the x-coordinate, right, the x-coordinate changes to 0.6. Right? Notice the y-coordinate doesn't change at all. Right? Then I call p.y, and I change the y-coordinate to 0 in this case. Right? And then I print out the result there. Right? So notice here, the x-coordinate doesn't change, but now the y-coordinate changes to 0.0. Right? And then I call set, and this time I pass in x plus 1 and y plus 1. And so here you can see after calling set, the coordinates of the point have increased to 1.6 and 1.0. Right? We've added 1 to both the x and y coordinate. Right? So calling methods on objects either returns information from the object, and sometimes here, when we use x, y, and set, we can change the state of the object. Here's another little program. All this program does is it draws a ball bouncing back and forth on the screen. Right? And so the way this works is that it uses a library written by some people at Princeton University called Standard Draw. Standard Draw just provides a bunch of methods that let you draw stuff to a window easily. And so we can run this program here. This is, where'd it go? It's Pong. So there's the program there as written in the slide. If you have the source code if you have the course source code, you can run this too, right? And there's your bouncing ball, it goes back and forth. Right? That ball is just a point, right? It's drawn as a circle. And so the point is just being moved back and forth on the screen. And so all that we're doing is changing the x-coordinate of the point repeatedly in a loop. Right? So we compute the next new x-coordinate, update the x-coordinate, draw the ball, and that makes the ball bouncing back and forth. Right? Slightly more sophisticated example. Again, there's just one point, right? But now it draws a bouncing ball. If you've done any first-year physics, this is just the projectile of a. This is just the physics of a simple point projectile. Right? When it runs into a wall, it knows how to bounce the ball in the opposite direction. Right? That is called bouncing ball inside of the course, inside of the source code for the course. Right? Here's an example of using scanner. Let me show you the Eclipse version of this. I'm never going to ask you to use a scanner in this course. If you want to use one, this little program here shows you the simple way to use one. Right, so if you want to write a program and you want to get some input from the user, so you want the user to type something and press enter and you want to get that string, one of the ways you can do this is to use a scanner. Right, so create a scanner, hook it up to system.in. Right. When you want to get information from the keyboard, you call the next line method. Right, and that waits, so in the terminal that's going to wait for the user to type something in and press enter. Right, when you press enter, the scanner will read that input and it'll store it in the string S in this case. Right, so for example, right, type in some text and press enter, so hello. Right, and then this program here simply prints out the value of S, right, so the value returned by the scanner. So there's an example of using a scanner object and calling a method using a scanner object right there. Right. If you want to scan a string, you can do the same thing with a string. So here I've got a string, 1 fish, 2 fish, red fish, blue fish. I can make a scanner that scans the pieces of the string. In this case, it's going to break up the words of the string using the space. Right. And so I have a little loop here. This is using a while loop. So hopefully they showed you a while loop in Python. There's also a while loop in Java, right? So while this condition is true, the loop body runs, right? So the hasNext method belonging to the scanner returns true as long as there's still some input left in the scanner, right? And so in this case, what it'll do is it's going to process this string, right? Every time you call next, it will consume one word in the string, right? So it splits up the string by the spaces, so when you call next the first time, you get the 1, right? You call it a second time, you get the fish. You call it the third time, you get the 2, and so on and so on and so on. Eventually, you consume all of the words in the string, and hasNext will now return false, right? There's nothing left in the string to consume. And so this thing prints out the individual words of the string, one line at a time, right? So there's an example of using the scanner. Again, I'm never going to ask you to use one. Okay, so I showed you how to read documentation for a class when we were talking about strings, right? So the way this lecture is set up is that we're now going to go off and look at the documentation for some class. We've already done that, right? If you want to know where the documentation is for the standard libraries, for the standard library classes, you can use this link here. This is for version 8. You just change the version number for the version of Java that you're using, right? And it'll take you to the appropriate documentation. In this course, it doesn't really matter which version of the language you use, right? So anything above 8 is fine. So this particular link, it would work just fine for our purposes, right? In the assignments, I will often give you a link for the documentation for the assignment classes, right? So for assignment 2, you get 2 links for the classes that you need to use, and so you have to read the documentation for those classes. All right, so that's the introduction to using objects. So we now know the basics about an object, right? So you know how to create an object, right? You create an object by using new and calling a constructor, right? You know the basics of calling a method or using an object, so you call a method using the dot operator, right? We don't care about destroying objects, and so now at this point, the rest of the course is basically telling you what other classes can you use to make objects, and how do we create our own classes to create objects. So the next lecture tells you how to make Java lists. So that's the lecture 8 called lists. Okay, so I have to emphasize something here. So you've seen arrays in Java, right? So when I showed you how to use an array in Java, I said, hey, look, Python's got these things called lists, right? Java's got these things called arrays, and the syntax between the two is pretty similar. What you have to remember is that an array is not a list, right? So in Java, an array holds a fixed number of elements, and it always holds a fixed number of elements, right? An array of length 10 of type int always has 10 ints in it, no matter what you do to it, right? And that's very different than what a Python list does, right? A Python list holds a variable number of objects. Java also has a list type, actually several list types, right? So lists in Java also exist. Problem is Java lists are harder to use well, it's more cumbersome to use a Java list than it is to use a Python list. Right? However, they do provide similar functionality. Right? So the syntax is very different, right? But stuff that you can do with many of the things that you can do with a Python list, you can also do with a Java list. Right? But remember, a list is not the same thing as an array. Right? One of the, I guess one of the things you have to get used to if you're coming from Python is that Java lets you pick between different kinds of lists, right? Whereas in Python, if you write square brackets, you always get the same type of list. Right? So in Java, there's two main types of lists that you might consider, right? But the one that you normally use by default is array list. So it's this thing called array list. Right? Click on that link there if you want to see the documentation for that class. Okay, so there's significant differences between Java lists and Python lists. Right? One of the biggest, probably the biggest difference, especially for the way that 121 is taught, is that Java lists, they always hold elements of a single type. Right? So you know in Python, you can put whatever you want in a list, right? I make a list, I can put in an integer, then I can put in a floating point value, then I can put in a true-false value, then I can put in another list if I want. Right? You can do that in Java, but the way you do that, you have to do that in a very specific way. Most of the time when you use a list in Java, it's a list of a single type. So you can have a list of a bunch of integers, you can have a list of a bunch of booleans, you can have a list of a bunch of lists, which is fine, right? But normally you don't mix the element type in a Java list. When you specify the type of a list, you normally specify what type of element is in the list. Right? And so you use this funny notation where you use the less than and greater than brackets, right? The angled brackets. So I'll show you what this looks like right here. Right? So if I want to make a list of strings in Java, normally what you would write is something like array list and then angled bracket and then the element type. Right? So that's an array list of string. Right? Pick a variable name. I normally use T for lists. Right? And now I need to make the list. So how do you make a list? Well, a list is an object, so you use new. Right? What's the name of the type? Well, the type is array list string. So now I write array list angled bracket string, round bracket, round bracket. Right? So this calls the array list constructor, makes a newly created list of strings. Right? This is very cumbersome to write, right? Array list string here, array list string over here. So in modern versions of Java, you can leave the element type out here. Right? So you can just write new array list here. Right? So you don't have to repeat the element type on both sides. You need it on the left-hand side. You don't need it on the right-hand side. Depending on who taught you Java, if you know Java from the past, you might know that you can write var on the left-hand side here. I don't show you how to do that. Anyway, you had a question? Sorry? Parenthesis here? Because you have to call a constructor, right? When you use new, you always call a constructor. To call a constructor, it's like calling a method or a function, right? So you need the round brackets to indicate that this is a method call. Okay, so there's once you get past this step here, right? So, okay, I have to put in the element type inside angled brackets. That's not so bad, but you have to remember to do it, right? Once you get over that hurdle, there's another hurdle that you have to get over, right? Usually, or often, you'll want to make a list of primitive elements, right? So I want a list of int. You can't do that in Java. So if you try to write that in Java, Java barfs, right? The compiler says, I can't do that, right? And so this is a limitation of what's called Java's generic type mechanism. Well, I'll explain in week 10 or 9, we'll learn all about Java generics and how to implement them. But for now, remember that you can't make a list of primitive type. Right? You have to do something else. Right? So if you want a list of primitive type, what you have to do is you need to make a list of what's called the wrapper type for your primitive type. So in the Java language, every primitive type has a corresponding wrapper class. Right? I got your question in just a second. Okay, so the type little b Boolean has a corresponding reference type big B Boolean, right? The type car has a corresponding reference type big C character, not big C car, right? Big C character. Why this is not consistent, I don't know. Right? The same is true of int, right? Int has a wrapper class called integer. Double has a wrapper class called big D double. Sorry, question. Oh, so what are generic types? Okay, so the answer is going to be slightly long. So if I want a list in Java, right? So I told you that a list in Java stores elements of a particular type, right? So you say array list of string, right? If you can imagine how whoever created the array list class created that class, right? So someone had to define how this class works, right? So someone wrote some code that defines how an array list works, right? If the element type matters, right? So an array list of string is different than an array list of integer, it's different than an array list of double, right? Whoever wrote the class probably didn't want to write a different class for an array list of string, and a different class for an array list of integer, and a different class for an array list of whatever, right? And there's an infinite number of classes, so they couldn't do it even if they wanted to, right? So there has to be some mechanism where you can let the type vary, right? Here, right? So if someone makes an array list of integer, you would like the underlying implementation to be the same as an array list of string, right? This is probably very abstract for you at this point in time, right? And so the mechanism that lets you do that in Java is called generic. It's called the generic types. So in this case, an array list is a generic type because the type of the element is a parameter to the type, right? An array list of string is different than an array list of integer, is different than an array list of double, right? And so a generic type is something where the type needed by the class changes. Question? Yes, that's exactly what's happening. Yes. That's exactly what's happening. So the limitation of Java's generic mechanism is that it doesn't work with primitive types. Yes, that's exactly it. Yes. Sorry, repeat the question. So when you write array list string, yeah. No, you don't know yet what array list is doing internally. All that you know is that array list can hold 0 or more strings. That's all that you know at this point, right? I haven't told you how it works, right? There might be an array inside an array list, there might not be, right? In a few weeks, you'll learn exactly how this thing is actually implemented. Well, it turns out it is an array in this case. So yes, internally there is an array, but because it's a list and its size can change, it's not always the same array. Yeah. All right, so every primitive type has a corresponding wrapper class. So if you want a list of float, you make a list of big F float, right? If you want a list of car, you make an array list of big C character instead, right? So the way the wrapper classes work is that they get special treatment by the compiler. Right? The compiler will try to convert between a primitive value and the and the wrapper type without you having to say anything special. Right? So here I have an int I, right? Its value is 1. Right? Remember, the wrapper class corresponding to int is big I integer. So the language lets you convert an int, in this case I, right, automatically to a wrapper class object, right? So I can make a big I integer object, right? Give it a name j, and I can store the value 1 in that, and that works, right? So what happens here is that the int value here, right, that gets used to create an integer object whose value is 1, and you store a reference to that integer object in j, right? So that's called auto boxing. right? Convert a primitive type to its corresponding wrapper type. You can do the opposite, sorry, the other operation. So you can take the value from a wrapper type. So in this case, I can get the value of j, and I can put that into an int variable k, right? And so that's called auto unboxing, right? Use the object referenced by j, get its integer value, and store the integer value in k, right? Normally, with all the other types, so if you make your own type, you can't do this. You'd have to write a method to convert the int to an integer, and you'd have to write a method to convert the integer to an int, right? But the language treats the wrapper classes in a special way, and you can use them almost seamlessly with the primitive types. Right? So if you want an array list of int, make an array list of integer. Right? If you want an array list of double, make an array list of capital D double. If you want an array list of car, make an array list of big C character instead. Right. Okay, so this looks complicated, and it is complicated, to be blunt, especially for a new programmer, programmer new to Java, right? This looks very cumbersome. It is, right? It's just the way the language works, right? But once you get past this step here, you can basically treat the list as though an array of int, right? So here I've got an array list of integer, right? You can more or less pretend everything inside of it is an int, right? So how do you add an element to the end of a list? The method is called add, right? So t.add. I guess in Python it's push, right? So add, and then you an element whose type is compatible with integer. So I can add the int 100 to this list, and everything works fine, right? Java takes the 100, converts it to the integer 100, stores the integer reference in the list, right? So auto boxing happens here. Everything works just fine. Right? How do you get an element from the list? So remember, in Python, you use square brackets. You can't use square brackets with reference types in Java, unfortunately. You can use them with arrays, but not with lists. So for Java, you have to call a method. The method's called get. Right? You pass in the index here. So tget0 gives you the first element of the list if the list is not empty. Right? So what's the first element of the list? It's the integer, 100, but you can store the big I integer in an int, no problem. Right? Java converts the integer to an int, or extracts the int value from the integer and stores it in first, right? And it does that seamlessly for you. So even though you have to use the wrapper types, you can just make believe that, in fact, you have a list of primitive type. Except if you want to call remove, right? So if you want to remove an element from a list and you have a list of integers, this is where you can run into a problem. Right? The problem that you run into here is that there's two versions of remove. Right? One version of remove takes in an int, and that uses that as an index. So tremove 100 says remove the 101st element from the list. Right? It doesn't remove the value 100 from the list. Right? If you want to remove the value 100 from the list, now you have to make an integer object whose value is 100 and call remove with the integer value 100. Right? So this is the only situation where you can't pretend your list doesn't contain just primitive values. It actually contains reference types. Okay, so I think that's enough for today. We'll pick this up on Wednesday.